So in this video, we look at how to calculate or solve problems that involve percentages or calculations of rational numbers. If you remember, rational numbers could be percents, they could be decimals, they could be fractions, they could be lots of different things. But first, let's start with percentages. What does percentage mean? A percentage is representing a piece of a number or part of a whole. For example, if I say 20% of all 8th graders, like the Redskins, that would be a part of the whole. Part of the 8th graders, 20%, out of all of them, like the Redskins. This proportion is a really easy way that we can use to solve these problems. If we remember that the percentage is always going to be out of 100, and that's going to equal part over the whole, or another word that we could use is the total. Okay? But the percentage is always going to be out of 100. That's really important to know. So let's look at a couple of these examples. This first one says 65% of 8th graders at Mark Twain have 10 or more tardies. If there are 550 8th graders, how many have 10 or more tardies? Well, 65%. So 65 out of 100 is equal to, well, here's what we have to figure out. There are 550 8th graders. Is that the total number of 8th graders, or is that part of the 8th grade? If you said that that's the total, you're right. And so then we put X here. That's what we're trying to figure out. When we're solving these proportions, it's pretty easy. We're going to multiply the two numbers that are across from each other. In this case, 65 times 550. And then we're going to divide by 100, which is the third number that's left out. We get 357.5. You can't really have half a student, so 357 or 358 would make a little bit more sense, but that's just how the problem worked out. When you're solving in proportions, it's kind of easy to think about, you multiply the numbers that are together on the date, and the third wheel, the one that's left out, is the one that's dividing them, if you want to think of it that way. Okay. If we look at it over here, this one's a little bit different. It says Marcus has 5 pairs of Nikes and 7 pairs of Vans in his shoe closet. What percentage of his sneakers are Nikes? Well, we know that the percentage is out of 100, but what we don't know is what percentage. They didn't give us that. So what we need to figure out is what's our total, what's our part. Well, they want to know what percentage of his sneakers are Nikes. Well, he has 5 pairs of Nikes. But how many shoes does he have total? If he has 5 pairs of Nikes and 7 pairs of Vans, well, that means that he has 12 pairs of sneakers total. And so that's going to be what fills in the last part of our proportion. So now if we go to solve this, 5 times 100 is 500 divided by 12. We get 41.666666666%, so I'm just going to round that to 42%. And that's that. We can also solve problems if they give us information in a graph. So this is a circle graph, and it shows the cell providers for the students at Twain. They said that 650 students were surveyed or asked how many have Sprint. Well, what do we know about Sprint? Well, Sprint is 16%. So 16% out of 100 equals, well, again, here we have that same issue. What's our part? What's our total? Well, we know that 650 students were asked. Is that part or is that total? 650 students were surveyed. That says we're surveyed total. If it was part, it would have been 650 students have Sprint. So X is going to go on the top, that 650 is going to go on the bottom. And now we can go ahead and solve this proportion. 16 times 650 divided by 100. We get that 104 students have Sprint. So a lot of these are kind of repetitive. Again, if you always remember that the percent is out of 100, the hard part is knowing which goes on the top and which goes on the bottom for the other half. But if you can remember part over total, that might make your life just a little bit easier. Let's look at this fourth one. On Friday, Edison sold 70% of the tickets they had for Mamma Mia. If they sold 180 tickets, how many tickets did they have total? Okay, well, 70%, so 70 over 100, equals, again, the total goes on the bottom, the part's on the top. So let's think. They sold 180 tickets. How many did they have total? Where does that 180 go? Is that part of the tickets that they had, or is that the total number of tickets that they had? If you said that 180 was the part, or goes on the top, you're correct. They sold 180, which was part of the total number of tickets that they had. What we're trying to figure out is how many tickets they had total to sell. So here we go. We're going to multiply 100 times 180 divided by 70. And we get 257. I'm just going to round that instead of the 0.1 blah blah blah. So they had 257 tickets to sell total. They sold 70% of that, which ended up being the 180. So again, the percentage side should be a little bit easier. Over here is where you have to kind of think about it. If you have questions on that, please come and see me. Please, please, please. On the back, we're going to look at some practical problems, kind of like these, but they all involve different types of fractions and decimals and things like that. So on the back, it says, how can we solve practical problems that involve rational numbers? If you remember from our first unit, rational numbers can be percents, decimals, or fractions. Typically what I notice is that the fractions are the hardest for you all to work with. And so in reality, there's more than one way that you can work with them. And so I'm going to show you two different ways when you're dealing with fractions that you can use to kind of solve or figure these out. So this one says, Miss Sullivan noticed that 5/8 of her students liked soccer instead of football. If she has 32 students in her class, how many liked soccer? So kind of like what we were just doing with the proportions, we could use a proportion to figure out what 5/8 of 32 is. Well, if 5 out of 8 kids liked soccer, how many out of 32 kids like soccer? And we would set it up just like that, where we'd have 5 times 32, oops, that's 160, divide that by 8, and we find that it's 20. So that's one way that we can work with fractions. We could also do something else. This one says that White's farm has sold 3/4 of all their Christmas trees. If the farm had 180 trees at the beginning, how many do they have now? Again, we're trying to figure out what's 3/4 of 180. When you hear yourself asking what is of, the of is really you're multiplying. So what is 3/4 of 180? And we can multiply 3/4 times 180. So 3/4 is 3 divided by 4 times 180. It's 135. So either of these ways work when you're dealing with those fractions. It really just depends on what your personal preference is, what you like better. But either way works just fine. So let's look at some of these examples on the bottom here that involve rational numbers, and let's see if we can figure these out. Okay. So this first one says that Blake bought 32 shirts for the drama club. Each shirt costs $1.55. If 5/8 of the t-shirts were green, how much was the total cost of only the green shirts? Okay, he bought 32 shirts, but they're not all green. 5/8 of the t-shirts were green. So what we need to figure out is, what is that 5/8 of 32? Well, we could either use a proportion or we could multiply them together. I'll use a proportion for this one. So if 5 out of 8 shirts are green, how many are green out of 32 shirts? 5 times 32 divided by 8 is 20. So that's one part. Because we're trying to figure out the cost of the green shirts, but each shirt costs $1.55. So if he buys 20 green shirts, and each shirt costs $1.55, we're going to multiply those together to find the total cost of the green shirts. $31. Okay? So a lot of these problems, they're not necessarily hard, meaning the math is easy. You're just multiplying, dividing, adding, and subtracting. But it's really important that we're reading the problem carefully and getting all of that important information and figuring out what the question really wants to know, because they will try and trick you. Let's look at this one. A librarian placed one book on a shelf and is trying to see how many more books will fit on a shelf. If each book is 1 1/4 inches wide, how many more books will fit on the shelf? Well, the shelf is 65 inches. We're trying to figure out how many of these books could fit on this shelf. So we're taking this and we're seeing how many pieces. Hopefully, that reminds you of an operation called division, because we're going to be taking this 65 inches and dividing it into equal pieces. Each piece is going to be 1 1/4 inches. But let's figure out what 1 1/4 is. If you don't remember your mixed numbers, 1 1/4 means 1.14. 1 divided by 4 is 0.25, so that's 1.25. So we're taking 65, we're seeing, okay, how many pieces, or how many times can we fit 1.25 into that? So we're going to be dividing. When you divide those together, you get 52. But here's the thing. There's already one book on here. So when they say how many more books will fit on the shelf, we have to realize, well, they already have one there. So it would be 51 more books. And so I know that that's kind of annoying. I understand. But in the reality, they're going to ask you trick questions like that. You kind of just have to think about it and pay attention. Okay. So I really like this next question, because if you ever go to the grocery store or the deli or anything like that, they're using a price per pound. Okay? And so when you have a price per pound and you buy more than 1 pound of it, to find out how much it costs, they multiply the weight by the price to figure out the total. So this problem says, at Wegmans, Mr. Izaga buys 3 pounds of chicken wings for $4.99 a pound and 2 pounds of French fries for $1.69 a pound for a staff lunch. If there's no tax on these items, what was his total? Well, first we have to figure out how much the chicken wings were. He bought 3 pounds and they cost $4.99 a pound. So we're going to multiply those together. 3 times 4.99. That's $14.97. He bought 2 pounds of French fries, and each pound of French fries is $1.69. So we're going to multiply those together. 2 times 1.69. That's 3.38. Now they wanted to know what his total was. So we're simply just going to add those up. 14.97 plus 3.38. $18.35. Okay? So sometimes the problems really are just that easy. You kind of just have to think about it for a second. Sometimes they ask about change, like how much change would they get, and that just adds another step to it. So be on the lookout for that. Okay, let's look at this last example. During the winter candy sale, the SCA sold 3/5 of their Skittles and 7/8 of their M&Ms. They had 100 of each bag, so how many bags of candy did they sell during the sale? Okay. Well, let's figure out how many Skittles they sold. They sold 3/5 of the 100 that they had. So 3/5 of 100. Again, you could use a proportion for this, but I'm multiplying them together this time. 3 divided by 5 times 100, well, that's 60. For M&Ms, they sold 7/8 of their 100 bags. 7 divided by 8 times 100, well, that's 87.5. I'm not exactly sure how they sold half a bag, but maybe somebody ate half the bag and then they didn't like them. So let's think. If they sold 60 bags of the Skittles and set 87.5 of the bags they had for M&Ms, how many bags of candy did they sell during the sale? Well, they sold the 60 bags of Skittles plus the 87.5 bags. So they sold 147.5 bags of candy during the sale. So there's an activity that goes along with this. They also have a homework assignment. So these questions are all a little bit different, but the idea of the math is kind of the same. You are figuring out, calculations. Like I said, you're really just adding, subtracting, multiplying, or dividing, and all of them are rational numbers. So sometimes they're fractions and whatnot. So just my advice to you is to read the question carefully, don't overthink it, and please, 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 if you need help, come and see me.